Hello everyone, thanks for joining us and welcome to Open Infra Live. Open Infra Live is an interactive show sharing production case studies, open source demos, industry conversations, and the latest updates from the global open infrastructure community. This show is made possible through the support of our valued members, so thanks to them. My name is Thierry Carrez, and I will be your host for today's show. We are live streaming on YouTube, LinkedIn, and Facebook, and we'll be answering your questions throughout the show. So feel free to drop your questions into the chat section of your streaming platform of choice, and we will answer as many as we can. Some of the most popular episodes on Open Infra Live are the large-scale OpenStack show, where operators of large-scale OpenStack deployments come and discuss operational challenges and solutions. Today, the large-scale OpenStack show is back for an ops deep dive into Schwarz Group's OpenStack deployment. You might better know the Schwarz Group under its popular retail brands like Lidl or Kaufland. They have a large and growing deployment of OpenStack to support those brands. Joining today, we have Belmiro Moreira, formerly at CERN, Mohamed Nazer from VexHost, Arnaud Morin from OVH Cloud, and they are joined by Felix Hüttner and Ihtisham from Schwarz Group. So to get it started, I'll hand it to you, Belmiro.
Thank you, Thierry. Welcome everyone, but especially to Felix and Ihtisham. It's great to have you in the show to know more about the open infrastructure in the Schwarz Group. So let's get things started. I think the first question for you, both of you, is tell us more about you. So how you are now in the open infrastructure field.
Then maybe I would just start. My name is Felix Hüttner. I basically started with the, let's say, OpenStack endeavor back in 2018, when we started StackIt as a brand, and a whole idea of we build our own internal and maybe potentially at some point public cloud environment. And have been following OpenStack and all the associated things we need for that ever since.
Yeah. So I'm Ihtisham, and my journey with OpenStack basically started when I was writing my master thesis with SUSE, and in 2019. And since the past 2 years, I have been part of StackIt as well. To work on the infrastructure OpenStack.
All right, so both of you work in the Schwarz Group, in the IT section of the Schwarz Group. So I didn't know the Schwarz Group, but I know some of the brands that belong to the Schwarz Group. Actually, I shop like every week in one of them, like one of very well-known, at least in Europe, is Lidl. But there are so many other brands, right, that this group has. Can you tell us more about the Schwarz Group?
Yeah, so the Schwarz Group is definitely most known for retail brands, Kaufland and Lidl, but we actually started a lot of other businesses. We have water bottling businesses, we create our own chocolate, ice cream, some parts of meat, our own recycling companies, and similar things like that. And since we have a large IT base, there was also the discussion, what do we do with that? Do we maybe want to open the cloud we build for ourselves also to the public?
Right. So at least now my understanding is, of course, Schwarz Group has the IT parts, but you guys also open to outside, right? So you have your own infrastructure that can be used also by other customers. And you create your own cloud infrastructure. And you name it Cloudit, and that's it.
It's StackIt. So basically,
StackIt. Yes.
And it's a child company of Schwarz, and basically It's a separate branch from Schwarz IT itself. So this StackIt is mainly focused on cloud platform and providing services to Schwarz IT and as well as public customers.
Right. So as the large operations group here, so we are interested to know more about this infrastructure. So what you can tell us about to have your own infrastructure and not going to a public cloud. You needed to build all this infrastructure. I believe you see a lot of advantage of that. Can you let us know more about it?
Yeah, the main advantage is the control and self-sufficiency we have using that, and not relying on some potential external large provider where we don't have any possibility to fix things when they go wrong. And on the other hand, the IT part of the Schwarz Group is not that small, so there's definitely a commercial aspect playing into that as well, where we see quite big benefits, which is why we also offer that to the public, or why we also want to offer it to the public.
And of course, you are using OpenStack for this infrastructure, right?
Yeah.
So can you let us know more a little bit about the architecture that you guys are using? How you deploy it? What is behind of your infrastructure?
Yeah, we started back in 2018 with a quite small-scale infrastructure, which had more control nodes than actual compute nodes, which was not that ideal back then, and scaled it now up to something around 400 compute nodes, 60,000 cores, and things like that. Right now, it's all deployed using our custom-built or self-developed deployment tool named Yaook. We previously used a tool from an external supplier, but the control we have using something self-built is just a lot greater and a lot or extremely helpful for us ourselves.
Yeah, I actually had some questions on that as a follow-up. So when you were taking the decision to use a deployment tool, obviously there's a couple of available ones that are kind of like upstream, and then decided to pursue your path. So what was your main reasons to why you wanted to pursue the path of building that tool?
We saw a few drawbacks with existing tools, especially regarding automation of, let's say, they do things where our feeling was a lot of these are based on at least some manual trigger or some manual starting of some kind of action. And what we built here and what we thought about was building Yaook based on a Kubernetes control plane, and not building it using a deployment tool like Helm, which will just say, this is the infrastructure, I apply this now, and I will pray it will stay correct and healthy for the next years. But rather using operators which will regularly reconcile states and can fix potential error conditions. And that thing paid back off quite a lot of times. I guess everyone knows the quite famous or infamous RabbitMQ, which might sometimes not work as well as you would like it to have.
It's always a topic, Rabbit, in these shows.
It's the greatest topic. But using operators, we actually made it quite easy to rebuild such a cluster, even if it's a high available cluster. So we could just say, we delete the data, we delete the currently running processes, and operators will fill back up all users that are in there within just a few minutes.
Of course, this means that you will lose some messages, but you don't care about those, right? As operating a large scale.
A lot.
Right.
So, and honestly, all messages that we lose were from Neutron, because the Neutron RabbitMQ is the one that always dies if you split it out. So there was not that much time we lost. You always have the issue that you might lose information needed for things like billing and stuff like that, which is something where we needed to build some recent logic around.
Do you still deploy the RabbitMQ in a cluster mode or only single process?
Yeah, it's a HA cluster combined with TLS on the cluster protocol layer, which is something that I feel is not that common because it's a little broken. And we quite regularly had issues until I think 4 or 5 weeks ago. We basically could count on it that RabbitMQ dies on Friday afternoon. We don't know why, but it always died on Friday afternoon. But back then we found basically an option in RabbitMQ regarding CPU scheduling, which brought it now to running for 4 or 5 weeks completely stable. And we are extremely confused that this option is set per default and that we took so long to actually find it.
Yeah, I would start knocking on wood at this point. Yeah.
So I saw your presentation that you gave in the Open Infra in Berlin this year. It was a great presentation, and you showed some numbers there about the size of your infrastructure. It would be great if you can let us know more about it. And that raises, because they were relatively large numbers. So you are managing these like a huge OpenStack cluster, or then you have several clusters and then you aggregate all these numbers?
At the moment, it's one large OpenStack cluster with all the 400 or so compute nodes in it. We are thinking about splitting that up in the future because while it can probably scale a little larger, there is definitely at some point a limit where we want to go, where we don't want to go above. And on the other hand, we are thinking about also how to put that into our failure regions or failure domains that we want to offer to our users. Because the common failure domain of AZ being some kind of data center, like a physical location, is from our perspective not always the most helpful one if you then have one large OpenStack deployment over. Because probably the OpenStack deployment dies a lot more often than the physical data center breaks down. So we are thinking about actually redefining one OpenStack cluster as being one availability zone here.
Right, so having different OpenStack clusters, and then you define different availability zones on them, right?
Yeah, and basically we say this OpenStack cluster is availability zone 1 or something like that.
Okay.
So you're not going to use AZ, you're going to use regions instead of AZ, right?
Yeah. Which brings quite a few challenges, like no stretched layer 2 networks and things like that.
Yeah.
But it's the path we believe is currently the best one, but it's also not yet in existence. So maybe we still find blockers down the road there.
Okay.
Okay, it's interesting. I think we had a question.
No, I don't think so.
No. Okay.
Oh, we actually have one question now. One question from Kurt Garloff. Maybe.
Perfect.
Yep. So, do you experience scaling challenges with Neutron with more than 400 compute hosts using OVAs? That's what Kurt has seen in the past. So, do you encounter those limitations?
I would say definitely yes, but not definitely as scaling challenges, not necessarily a hard limitation on what you can scale up to, but I think a large amount of that scaling challenge then comes from the amount of update messages running through RabbitMQ, which just increased to a crazy number. And a thing that we have found out, but that might be quite unique to our environment, is remote security groups. We have a user base that, at least in some part, uses quite large amounts of remote security groups, like referring to 2,000 and more ports. And that definitely slows down the Neutron Open Research Agent when it needs to load this information for the first time.
And yeah, just to add to that, I mean, with so many compute nodes, you have more customers that are there and more routers. And we had some issues with limited number of gateway nodes, and which basically killed our gateway nodes. So we have to extend them and distribute the routers, throughout them evenly, so we can accommodate for all those compute nodes and all the routers from the customers.
Are you using the DVR stuff on the Neutron side, or
No.
Okay, so gateways are even used.
Yeah.
I think as an OpenStack large-scale users, as we are, we always reach these kind of problems, right? One of them was RabbitMQ that we already touched, and the other is Neutron scalability. Yeah, and maybe we need to find a way to try to overcome these issues, because they are always popping up, right, in our discussions.
Well, the cool thing about the RabbitMQ site is there was a recent effort that was surfaced, and it started was a discussion in the OpenStack discussion mailing list. And there's some efforts of a group of individuals that are trying to work together in order to implement a NATS driver. So NATS is an alternative messaging queue system. It kind of relies on I think it's a CNCF incubated project. So it's gotten a lot of traction behind it, and there's a lot of big users for it. So I think there's an initial draft for the Oslo messaging driver that like needs tests and the spec needs to work on and everything. But if anyone's watching that's kind of interested, I suggest kind of looking at that effort, because I think that's it could definitely be a solution for a lot of these issues that we're seeing. But on the other hand, on this, I don't want to say that I'm skeptic, because I encourage this. I think it's for it, but I think one of the community members once brought this up, and I think it was in a TC meeting. I think it was Dan Smith, and he said, at least with RabbitMQ, we know how it breaks. We have a lot of experience on how it breaks. And potentially something else, we don't know how it breaks. And so maybe taking the thing that breaks, the thing that we know how it breaks is better than taking the thing that we don't know how it breaks yet.
Yeah, which is completely fair, right?
So it's two hard choices.
Yeah, but also NATS is a completely different technology. We cannot compare really one-to-one to RabbitMQ. So probably there are a lot of use cases for people that use now RabbitMQ that NATS will not be an option. Right, so the reliability of sending the messages that the RabbitMQ offers on NATS, that will be more difficult.
Yeah. So at least our idea to solve this problem is to basically get rid of RabbitMQ and go towards OVN. So at least at least with Neutron, we don't have these issues with messaging at all. So right now, we are going in that direction. We are implementing the OVN integration into Yoke. So we can move towards no RabbitMQ, at least for Neutron, because that's the most painful one. For the others, we also contributed, and we are willing to contribute to the net driver or replacement for RabbitMQ. So let's see how it goes.
I think you tried on your side quorum queues on RabbitMQ, right?
We are building now up a new environment, because our existing environment is based on the nice and old version of Queens. And we like to get something not as horribly old as Queens. So we are building a second environment currently based on Yoga. And that will have quorum queues enabled. Unfortunately, we can't enable it for older environments just because it's not there in Oslo messaging.
Okay.
But until now, we didn't do load tests on it honestly yet. So let's see how well it behaves. At least it doesn't behave radically worse.
That's still good, and we hope it.
That's already something quite positive.
It's supposed to be the answer. But on the question of OVN, and I wanted to bring this up because that's something we've looked at. But I think one of the concerns with OVN is that, do you guys feel that it's still at feature parity? Is it going to support all your use cases? So, for example, something that we see often is customers that need VPN as a service, and VPN as a service is not something that's available with OVN right now. So, for example, that's one sample of something that kind of stuck out to me. I don't know if there's other things that are kind of slowly making their way in to reach that feature parity. But do you guys feel the disadvantages of losing some of the features of OVS, since it's been around for so long, are useful in return of the scaling advantages of the OVN driver?
I think we see these definitely. We are heavy use of the Neutron dynamic routing plugin to propagate the addresses of our routers using PGP. That's not yet there for OVN. There's a project that was also shown at a summit. I think it was the last session that was on the summit at all, which showed the initial version of a project, and we're now trying to make that work for us and potentially contribute things there. On the other hand, for the existing logic we have for OVN, we have tried to get it to break in some kind of way. And it's, from our perspective, significantly harder to break and significantly easier to restore than an OVS environment. We alone have for a current OVS L3 agent, if it needs to start up and sync all routers, that might take an hour or so. And with VN, we are at some minutes at most. And I guess there's a significant benefit also in not sending all these messages around. But definitely it's a big trade-off. And we are, for example, no user of the VPN as a service plugin. But what we see as a benefit, since we say we want to have multiple OpenStack clusters in some kind of way, we will have the requirement to connect them in one way or the other. And OVN has already a solution for it. There's an OVN interconnect project that allows you to interconnect different OVN environments. So it's a trade-off that might be worth it from our perspective.
Right. And on that same subject, actually, I'm curious, since you're running Kubernetes and OpenStack together, which is something that we do you guys focus on putting the infrastructure services also in Kubernetes, such as like OVN or OVS or libvirt, or do you actually run those directly on the host?
They are also, let's say, let's maybe shortly address Kurt's question. It's still a little incomplete. I was like an hour earlier than this, I was literally working on a patch for OVN to get IPv6 on external networks to correctly work, because they don't announce MAC addresses on failover. But I think on the overlay, it works extremely well. Or at least we didn't find anything there.
At least I forgot the previous question.
It was about running libvirt,
running
OVS.
Libvirt and OVS on the host versus the container.
So basically, yeah, we are like with our current OVN integration, all of it will be running inside containers, and with the libvirt as well, we are running it in the containers. So basically, whatever Yolk deploys it, all of it in containers.
Okay.
Yeah. The big benefit that we see with that is our deployment tool just needs to get the node into Kubernetes. The rest happens then via some kind of magic. What we do is, at least for libvirt, the people at OpenStack Helm had a really cool feature to let the VMs escape out of the pods, so that even if the libvirt pod or container dies, we're fine.
Yeah, so that's why we use OpenStack Helm, and I figured, how did you guys solve that challenge? So it looks like you're on the same route.
So while we're on the topic of OVN, we have a question from Florian. So you've mentioned that you would consider moving to OVN. Have you already worked on some migration path? Like, are you going to build everything from scratch? Are you making them coexist, or is there another solution that you've considered?
Okay, so basically, there are two things we are bringing in. One is we want to migrate to Yoga version, and or at the same time, we combine it with OVN. And basically, the part we are taking here is that we will do an offline migration for all the projects, one by one, from one cloud to the other. So it will be, not online, it will be offline, and we will migrate all of them from our current cloud to the new one that will be running on Yoga as well as with OVN. So we would not use OVS anymore.
Okay.
I look at Avno and I'm like, man, it would be nice if we had that privilege, but I think as public cloud operators, we will never have that privilege of just like shutting down everything.
I mean, it took us some convincing to get it. So yeah,
the basic rationale being that if we think about, I think it's 8 upgrade steps from Queens to Yoga. Our assumption is that something will probably mess up somewhere, either we or some kind of bug we will hit, and we will probably have a larger downtime with upgrading individual versions than with shutting individual projects down and migrating them.
Yeah, I think it's time to go back to Yahoo and try to understand. You already explained a little bit about the motivation of Yahoo. You guys developed your own OpenStack lifecycle management system. It's courageous to do that. But then you end up not only managing OpenStack, but also managing your Kubernetes clusters to run OpenStack on top of it. And I'm curious about all these hops involved on this, because a large-scale OpenStack is challenging to operate. Kubernetes as well. So how is your day-to-day operating these two projects?
At least from my perspective, there's a lot of things that went into automating, for example, common things like node deployments. So nodes coming up, initially registering themselves in some kind of management, being deployed by Ironic, getting a gigantic large config drive with Ansible in it that actually deploys Kubernetes on them and joins them into a cluster. And that's something that works extremely well automatically. There's always the general quirk of I'm some kind of hardware. I want to behave differently than everyone else. Sometimes they feel a little bit like cats because they just do what they want. But afterwards, it's an extremely smooth thing. So we have just a general inventory, netbox as tooling, and we just say, this is a compute node. And it gets deployed as a compute node. It gets labels in Kubernetes as a compute node. And the operators take care of the rest of actually deploying either the Neutron Open vSwitch agent or deploying OVN, and then deploying Nova Compute, libvirt, and all that magic on it, including monitoring and setup like that.
Well, the way you say it looks like very simple and that everything is always working, right? So in terms of upgrades, because then you don't need to you need to upgrade not only OpenStack but also Kubernetes clusters. I guess that will be a big challenge for you.
Our current plan or our current idea on addressing these is we not only have Kubernetes, we also have the host below it with all its nice and fancy system packages that might have vulnerabilities, patches needed, and things like that. And our idea is to actually not go a complex path, but to optimize our node deployment process so that we basically say we can now maybe take 1 or 2 of these 400 compute nodes and just undeploy them, wipe the disk, and deploy them completely fresh with a current version of Linux on it, potentially including a Kubernetes upgrade for this node as far as possible, and then going from there. So the idea is not to manage these things individually, but rather include them in the life cycle of the node and making this life cycle extremely short.
Okay, I see.
So it means you are able to live migrate a lot of instances in order to empty the computes. So you're using a lot live migration?
Yeah.
Okay. And no issue with live migration, no daily operation, no ops for that?
We had some issues, especially regarding the remote security proofs we mentioned earlier, because that caused the Neutron Open vSwitch agent to hang, and that meant that newly live migrated VMs couldn't get their port plugged and were like offline for 5 to 10 minutes. But other than that, it works quite well. For Queens, we have a lot of, let's say, workaround logic in there to make sure it works smooth. So for example, so in libvirt, you have the possibility to say how fast the VM should live migrate. So we turned it down to an extremely low number and then wait for Nova and Neutron to actually figure out everything on the destination host automatically check if everything on the destination host is fine, like if the ports are plugged, if the security groups are applied, and only then like release the migration speed and let the migration actually run.
So you have some custom patch in Nova for this?
Or more in our live migration logic.
Okay, so it's a tool or a bot or something around Nova to manage that.
Yeah, it's basically a part of your OOP that cares about emptying nodes and ensuring that it can do maintenance on these.
Okay.
And that has grown quite complex over the time.
Interesting. And what about things like just hardware incompatibilities, different kernel versions, different, the other stuff where it comes to live migration issues, or you haven't had too much problems with that?
Kernel versions were gladly nice to us for now, but we had we pinned the CPU versions of what we offer to our users, so that we can actually be sure that what we offer is also available on all hosts participating in this given host aggregate, so that we can be sure we can live migrate all instances around, which at some point makes it non-ideal, as we mightn't be able to offer the, let's say, latest CPU features to our users all the time, or only in maybe specialized aggregates and flavors. On the other hand, it allows us just to do this kind of maintenance. But we will have, for example, vGPUs coming up quite soonish, which makes the live migration idea no longer that valid, at least for these hosts.
Yeah, and for your live migrations, are your VMs using all block storage only? Are they some block storage, some local storage? Is it all local storage? What's your mix on that?
The most storage, or the most part, is on the central block storage. We have a small amount of things that we run on local storage, that being especially load balancers that are used by the Kubernetes service we are offering, because there's a lot of them, and because the image that they are using is just tiny and it's not worth the overhead of provisioning it on block storage. But there's just copying around 1 GB of disk, which is not really changing at all, so it's quite easy to actually do.
That is easy live migration. Like,
yeah,
if you have shared storage, it's easy live migration. Like my experience personally, I love live migration and it works great, but I don't have shared storage.
Yeah.
So we are transferring like 200 gigabytes images around, and that is sometimes doesn't go well.
Yeah.
True.
Yeah, we are not yet sure. We definitely have the requirements from our users to offer such things as local storage in the future, just because of the amount of performance it offers. And we're not yet sure how we will handle that now.
I think we have a new question.
Yes, we have a question from LinkedIn user who asks, don't you face issues with HCD when using central block storage?
I'm feeling a little bit confused regarding the correlation.
If I was going to guess, you mentioned you had a Kubernetes service. If I was going to guess, it's probably for your customers running their Kubernetes clusters and the etcd for their Kubernetes clusters that's going to run in the block storage.
That sounds possible. They use quite a lot of IOPS, and we have a different quality of service we offer to our users, and they are normally in the larger region of that.
Yeah. Do you have? Are you using, what sort of drives are you using for your? I'm assuming SEP cluster.
No, it's actually a NetApp-based storage.
Okay.
We are heavily benefiting from the deduplication it offers. We had a SEP cluster in the past. Yeah,
and is it using like NVMEs or SSDs or normal drives?
It's a fun combination of NVMEs and SSDs, if I'm correct.
Oh, okay, I see. Yeah, yeah, because I mean, in our case, we haven't seen too many issues, but we run NVMe for our block storage, and so maybe that's why we haven't seen any issues. But I think that's a good question, because depending on how you use centralized storage, it might be pretty slow.
Yeah, and we definitely needed to figure out a little bit what performance class we actually need to give to the LCDs, because they are definitely write heavy sometimes.
Yeah. A side question, kind of as we're discussing. So how are you building your images for Yelp? Are you using an existing OpenStack project's images for containers, or are you building out your own?
We are currently building them on our own. We had a fun discussion on the summit regarding actually combining that with the OpenStack upstream effort.
Right.
But there's not yet much progress in that direction. There's a few of them with 1 or 2 custom patches. For example, the Neutron Open Research Agent has a patch to like show the status of itself, so that we have some reflection of the status in Kubernetes. For example, if it can't finish iterations because of some error or because they take forever.
Yeah. And are you building as virtual environments, or are you installing just all the packages from the provider that you're using, or how are you kind of like, so install from source or from distro packages, and how do you manage that?
It's installed from source basically, and then pinned to the different stable branches that we want to use, or EOL branches for some things running Queens. Got it.
Okay, right, but there is a motivation to not use a Locky, for example, because I think, Mohamed, you are using Locky, no, in your images.
So we used to use Locky, but then we kind of like wrote our own little thing, mainly because what we started using is using a lot of the new features of Docker. So using things like multi-stage build, using the new front-end features so we can get clone directly from Docker. So there's a bunch of stuff that we did around that, but essentially the API of building our images is still the same as Loki, and we still use the bindep idea to get all the binary dependencies. But yeah, that's I guess a question also for them is, was there a reason for that or no particular reason?
I remember taking a look at Loki back then, and I'm not exactly sure, but we had issues getting it to fit quite well to us, and we needed to customize the images anyway because we wanted to put in like startup scripts or something like that. I know from OpenStack Helm they are mounted from quite interesting config maps that contain a large amount of bash scripts, and we wanted to actually bake these into the image.
Yeah, that makes sense.
And the OpenStack installation part is honestly then quite small in the image itself.
And so you built the OpenStack images yourselves. Everything, all the manifests are managed by the operator. And what about things like the infrastructure tooling? And when I say infrastructure tooling, I mean the RabbitMQ, the I guess Galera cluster or whatever form of database. Did you kind of have all that code? Did you rely on maybe some Helm charts to already do that? So what was how did you end up with that deployment aspect of Yaouk?
We actually started with the Helm charts and started using just the official RabbitMQ and Galera Helm charts. But we quickly came to the point that they don't necessarily support what we want to do. On the one hand, we wanted to have a TLS everywhere, which a lot of Helm charts might support for front-end traffic, but definitely not for replication traffic. And we wanted to have the possibility to use custom logic during upgrades, during recovery of a Galera cluster or something like that, which is extremely hard with the Helm chart.
Yeah, let's see. And
so that, sorry, Mohamed, this is interesting because you manage also your databases with your lifecycle tool. That's it. Okay, yeah. At least for me, that was always risky to do. I don't, at least in the way that we manage the databases, they are always in a corner. We have very little automation, touching schemas and so on. to avoid any issue. It's interesting that you guys feel comfortable to have this in your lifecycle management. I don't know if the others can comment. Arnaud, you are smiling.
No. I just think, just like you did, you said it's kind of risky, I think, but.
Yeah, because for us, we had bad experience at the beginning when we had the Puppet models always touching the databases. And yeah, we decided, let's stop this. And we only touch them manually.
Yeah, we actually had not that positive experience always with automated updates on database as well. But what we have as a benefit is that OOC itself, or the operators we build, they have an integration test logic. So we actually, for each change we do there, we spin up a whole OpenStack cluster, including Galera clusters, RabbitMQ clusters, and that allows us to catch the issues we would normally face with wrong images or wrong config files and stuff like that.
All right. Okay, interesting.
And then what about monitoring? So I noticed that in the dependencies list, you guys need Prometheus. So I'm assuming that is part of the monitoring infrastructure. So can you talk a little bit more about how you guys do monitoring, both kind of internally and inside your operator tool?
Yeah, that's something not completely part of Yoke. We have multiple Prometheus environments running that are federated between each other or doing remote writes. So that we basically in the end have one large Prometheus environment where we can query all metrics from all clusters and all environments, including down to the CPU usage of a single core on a given network node. I'm not sure how long that will scale. I guess we'll find the end of that at some time.
Do you have some? Yeah, sorry.
So I was just saying, you'll always find out something will scales to a point. You'll find out when you know. You'll know when you know. Sorry, I'm not. Go ahead.
No. I was just going to ask if you have some custom exporter for OpenStack metrics or anything fancy on that part, or is it pure regular exporters that we can find upstream?
It's an exporter for OpenStack. We query a lot of the database itself, because querying the API for such large amount of resources is, from our experience, not that stable and especially not fast.
Yeah, so that's what everybody's doing, I think.
Yeah. Well, something I've actually been thinking about that is in the one day to do if we have the time. But I think what could be really interesting is if we kind of have people move towards using something like UWSGI in a more standard way. There's something like UWSGI exporter that could probably start to track some interesting metrics on how long requests are taking, how many requests are coming back with a 404 or 400 or 200, and that way that can help get some measurable data out of that. So that's kind of one thing that I think is neat. The other thing is using MySQL exporters to generate stats. So for example, something that we have been thinking about is monitoring, for example, the instance faults table in Nova and using that to generate, for example, a metric of how many scheduling failures or failures that a VM didn't go up for, and then that way you can alert on that, because it's much easier to catch that in the database by monitoring it. Now, ideally, it would be nice if Nova or something like that exposed that directly, but that seems like a much more less intrusive thing to do than going into the code and starting up a service on an arbitrary port on all these extra OpenStack services that are running. So something I've kind of been thinking about, and I don't know what everybody else thinks about these ideas.
We actually do that, and I think it produces quite valuable things, especially to. So we mentioned live migration earlier. There's always the fun instance that has random states and that you can't easily live migrate. And that's the best location for us to figure that out. We get a metric for we have instance live migration errors and can then basically take a look on that.
Yeah, actually we do the same, and we started this like long ago. So we wrote a little tool that we call the blogger, like the database logger, that goes frequently to the database to extract some metrics and some information. That is not only for statistics, but also for alerts for the infrastructure. And we are running this like almost from the beginning. Because from the beginning, we felt the need to have a tool like this for our operations. And it works very well.
Yeah.
And for us, I would say we have a lot of alerting based on these queries from database. So we have the query exporter, which, And then I think we also have some exploiter from the gateway nodes for exporting some info of the routers. Directly from the gateways, but in combination with then we check how it looks like in the database and how it's in reality, and then based on that we create some alerts and metrics.
It's interesting that even in a different way, we are always doing very similar things, right? It's interesting.
About the routers, you said you were monitoring them because the database is not always reflecting what is on the network node, right?
So it could be that there are some zombie routers, and it could be the other way around as well. So we just want to make sure that both of them are in sync, and if not, then let us know. And it's kind of similar. We had issues with placement as well.
Placement?
We had similar issues with that the resource allocation there was not the same as no one was doing it. So we have some alerting for that as well. So we don't know why it gets out of sync, but at least we have some monitoring for that. We see.
I think when you will upgrade,
I think you just say it. You're going to say exactly what I was going to say.
I think it's in yoga for sure, a lot of placement issue will be solved. Maybe that's what you were going to say.
And there's also a tool. So I had initially, we had the same issues. I wrote a whole script to just go and clean that up. And one of our contributors, which I think was Sylvain, he took that and brought it into the Nova Manage tool. So now in the Nova Manage tool, there's actually a placement kind of DB audit command, which will go and make sure that placement and Nova is fully synced up and potentially clean up anything that shouldn't be there.
That sounds like something to check out.
Yeah, it's a lot better.
To clean up one more horrible Python script.
Maybe that.
Yeah, you cannot run an old OpenStack version for that. You need to run one of the latest. So that has not been a thing for us.
And just last question about the routers. Are you using the HA with KeepAliveD in order to have active and passive? Okay,
yeah.
Which works mostly well unless the network nodes are under a large amount of load.
Yeah,
and
we had
it all
similar issue. We had similar issue exactly because there is a lot of race condition between Neutron and KeepAliveD and between KeepAliveD itself, and it can end up with you can end up with a lot of routers not being correctly configured, or even being correctly configured but not correctly set in the database. So you think you have an issue, but you don't, or stuff like that.
Yeah. One of the things we did for a while is we have an exporter that goes and extracts the HA status for the KeepAliveD process, whether it's active or standby. And then we would kind of have alerts if there's a router that is standby and keep alive in all of them. So even though the database can say that it's active or standby or whatever, the reality is keep alive is saying it's standby across all of the network nodes that it's covering. So we would alert on that because that network does not have a single active router, so the VIP is not anywhere.
We had the similar, but the other way around. We have some multiple actives routers, and we had the alerting for that. So same issues.
And I'm wondering how much of that has to do with just like, at the end of the day, we are kind of using a bunch of x86 boxes to send a lot of traffic through. And that's just kind of historically known to be something that they're not great at. Obviously, we've got like DPDK and all these other hardware acceleration things that are available. But I think for the most part, a lot of the virtual routers don't really make use of those. And because of that, we're seeing, a lot of CPU usage and a lot of these throughput issues. And I don't know if you guys think that maybe having some hardware acceleration, especially when it comes on network nodes, would actually bring in a lot of benefits to this sort of thing.
There was a interesting session on the summit from, I think, Canonical and NVIDIA regarding the new DPUs NVIDIA is planning to offer, which seem to have some kind of, I'm not sure if it's integrated in Open vSwitch directly or if it's just a OVN integration, but that seems to do hardware offloading for example, external networks and things like that.
Yeah.
And we're thinking about actually checking that out once they are also available. Not sure what's the status for that.
Yeah, I know the ConnectX-5 and the ConnectX-6 also do VXLAN offloading, which is, I think, a big thing that'll take a bunch, but I don't know if that's the tell-all, fix-all thing, especially on the network nodes where it has to do NATs and has to do all these other features that have to be implemented inside of the kernel level, right? Like there's IP tables that have to be jumped through to get the NATing to work and all the other stuff that comes along. So maybe that's something that OVN does better at.
At least it doesn't need to go through IP tables and not through network newsletters and things like that. So I guess there's a benefit. And the DPUs that we saw at the summit were actually doing all of this in hardware.
Mm-hmm.
How well this actually works, I think is a question to be answered.
All right, so we heard everything about your architecture, how you deploy things, how good it is. So maybe now to know things that didn't went as planned, I think will be very interesting to close the show. So who deleted the database? Let us know.
I think that's why they wrote an operator, so they can say that the operator deleted.
They blame someone else, right? So it was the computer, not me.
Let's give it a name, and then we can blame them.
But yeah, so I mean, we had issues with when we were migrating our environment from the previous configuration management tool to Yoke, basically. And one of the bigger ones I would say was the Neutron migration. I mean, no surprises there. And basically, the problem we had there was that the version of we are running MariaDB on with our Yoke operators, and on our old environment, we were running an older version of MySQL. And when we migrated, basically, there was a flag in MariaDB, which was by default enabled, which is basically called a derived merge. And basically we have a lot of RBAC rules, and there was one query in Neutron which didn't like this derived merge flag, because basically this flag was introduced for some optimization, but in our case it was basically the opposite. And yeah, so that created a big outage basically, and took us some time to figure out what's the actual difference between our old environment and new environment, and go through all the flags and see what's new and what needed to be fixed. So that was one interesting one, I would say.
And the other one,
yeah, that must have been very difficult to debug, right? Like one flag and causing issues. It's especially in the database side, that is challenging, I guess.
We were literally going through all the parameters and seeing what's the difference are and what are enabled, what are disabled. Because other than that, our workload was the same, our Neutron versions were the same. So basically, the only difference was that our MariaDB and MySQL versions are different, and we were not expecting that there will be a flag which will be enabled by default, which makes sense that it's optimization. But if basically the problem is the way Neutron wrote the query, it didn't work. And there is actually an upstream merge request for it, which is still in review for fixing this query and make sure that it works with too many RBAC rules basically and is optimized.
But we spent the whole night there.
Yeah,
it was not so great.
And I think that is a great lesson. Like when you change something in your environment, you should do it in steps, right? If you have changed everything, upgrading, changing the database, that will be like a nightmare to find, right? Because then you can filter that to, this must be the database, something wrong there, and you can start investigating.
Yeah, basically, I mean, we did this migration on our stagings, but basically the production workload, the query was not so optimized for our production workload.
The scale is different.
It only triggers if you have a bunch of RBAC rules for the same network, but for different projects. And only then the optimizer actually changes something there. And that was really not something we were expecting.
Yeah. But Felix, you said that you have another one.
Yeah, another one for databases. That's at least like, I think 2.5 years old or so. But the issue we were facing there were basically the database servers were under a large amount of load, so basically at a limit of what they could handle, and the database cluster itself was falling apart randomly. The issue basically being the SMI or Galera replication thread running, and it just didn't get CPU time because the normal MySQL processes just took all the CPU time. The fix was equally easy after finding it. You can actually set a thread priority for that. And that ensures just this replication thread always gets CPU time preferred over everything else. And it also helped us. We had a change, I think 2 days ago. We changed the MTU of our external network, thereby touching, I think, every single router we have. And creating a database load of, I think, 220, I think, top set, when the server had like 60 cores. But thanks to that setting, at least the database cluster survived, even though it couldn't answer any query anymore.
All right. I was expecting something dramatic, like we had a hostage like for 1 week, or we deleted the database.
I think the maximum was 1 day.
We had a fire in the data center.
Gladly not.
Yeah, Lumira, you're saying things, and I don't want them to I don't want you to manifest things here. Can we manifest something else, like an easy upgrade or something other than these?
So thank you so much, guys. Do you have any other question to close the show?
I think that's it. Thank you for coming along, guys.
Yeah. Thank you so much.
Yeah, thanks.
Thanks very much.
Thanks very much. That was really a great discussion. I wish we had more time, but we're almost out of time. So I want to thank you all for joining us today. It's always a pleasure. Thanks again to the Open Infra Foundation members for making this show possible. And thanks to our audience for some great questions during this show. As you may know, OpenStack Z will be released next week. So we have another great Open Infra Live episode lined up that I'm super excited about. We'll have members of OpenStack deployment teams present their recent work and the exciting features that shipped with this release. Lots of technical content again, lots of opportunities for live questions about it. So make sure to subscribe to this channel on your preferred platform. Also, remember that if you have an idea for a future episode, we want to hear from you. So submit your ideas at ideas.openinfra.live and maybe we'll see you on a future show. So mark your calendars. Hope you're all able to join us on Thursday, October 6th at 15 UTC. Thanks again to today's guests and see you all next week on Open Infra Live.